Once Express completes the simulation, you'll see an animation showing how the part is deforming in the graphics area. Watching the animation can be really useful to help you verify that loads have been applied in the correct direction, and that restraints have been placed on the correct faces. More importantly, observing the deformation of a part in an animation can provide valuable insight as to how to improve the design. One other thing to notice here is this deformation scale in the upper left. Express intentionally exaggerates the deformation of the model on your display, so you can clearly see what the behavior is. In this case, it exaggerated it over 113 times the actual deformation, so you can clearly see how the part will flex when it's under load. Remember, one of the assumptions about using Express is that deformations must be small. If the results here were to appear at a 1:1 scale, it might be too small to clearly see how the part will behave. Full versions of simulation allow you to control this deformation scale, and even set it to a scale of 1 if you want to visually see the exact deformation. If the part deforms differently than you expected, you might need to go back and double-check the fixtures and loads to make sure they're applied correctly. This part is deforming as I'd expect, so I'll stop the animation and click the Yes button to continue viewing the results. Express provides results for stress, displacement, and factor of safety. Let's go through each of these so you have a clear understanding. Starting with von Mises's stress distribution, if I click the link in the task pane, Express creates a color-coded plot showing the maximum and minimum stresses on the model using von Mises's criteria. The full version of simulation offers plots on many other quantities, such as principal stress and strain. Now, a common misconception for new simulation users is that red is bad and blue is good. While that can certainly be the case in some tests, the color coding simply represents the maximum and minimum stress that the part is experiencing under the load. To interpret the results in a meaningful way, you must pay attention to the values in the legend. Notice at the bottom of the stress plot, Express shows what the yield strength of the material is. In this case, the yield strength of the material is much higher than the maximum stress shown on the plot. That would indicate that the part does not yield under the load we specified. At any point, you can play the animation and see the color coding animate along with the deformation. Let's get back to some of the other results. Notice Express shows there are also results for displacement and factor of safety. These results plots can also be activated from the study tree, simply by double-clicking. I'll double-click the displacement plot to see those results. It again uses a deformation scale of over 113, and the plot graph shows you the actual maximum and minimum deformations. Keep in mind the units used in the graph are controlled by the units specified from the Welcome tab in the first step of the Express Wizard. SolidWorks also lets you see the deformed shape of the model without color-coding the maximum and minimum, while using the same deformation scale. The final result we'll go over is factor of safety, which we'll discuss in the next lesson.